So this is a geometric proof problem, and what you have to do in these sorts of things is use your knowledge of circles and lines and the way angles interact to try and prove something that they're asking for. So let's see what we're given here. AE is this line right here. BD is this other line, and we're told that they intersect at C, which is the center of a circle. So that's useful information. C is the center. And we're also told that DE is a minor arc, right? That's what this means. Minor arc DE is 64 degrees. So we're given that right there. And we're asked for CDA. So I always like drawing things on the picture that I'm given, just to make sure I understand what I'm working with. CDA is this angle right here. And I'm told we need to figure that out. So let's start working with this. And I don't want to imply at any point that you can always solve these sorts of problems. Sometimes not enough information is given. So that is an answer that may happen. Let's get into this now. So if I have a minor arc DE of 64 degrees, that means this angle right here is 64 degrees. That's one of the properties of circles. Minor arcs correspond to the angles with the center point. So if that angle is 64 degrees, because these are two intersecting lines, that means this opposite angle over here is 64 degrees. Those will always be equal. But I want to figure out what the blue angle is. And that's a little difficult at the moment. I'm going to need some more information about that triangle. Triangle ACD is where my focus is right now. How can I figure out, let's put this in a different color. How can I figure out this angle right here using a knowledge of the 64 degree angles to the side of it? Well, think about this. See these two angles that I'm drawing in green? If you add up the two green angles and the two red angles, the result must be 360 degrees. So I'm going to say 360 degrees equals 64 degrees plus 64 degrees plus, let's just call that green angle, I don't know, x. Let's call that x plus x plus x. Okay, so we can solve this. Pull out a calculator, say 360 minus 64 minus 64. That means 232 equals 2x, which I'm going to be careful here and just let the calculator do it for me. 116 degrees equals x. Okay, that's helpful. What does it do for us? How can we use this knowledge of this green angle right here to solve the figure? Well, you have to understand that the triangle that's drawn here, ACD, is an isosceles triangle. In other words, it has two equal angles. This angle right here is equal to this angle right here. And the reason that's true is because, see this 64 degrees over here? That's the same as this arc over here. That is also 64 degrees. And because of the symmetries of the arcs of the circle, that means the angles in this triangle are also symmetric. So let's use that idea and now say this. I'm going to stay in blue here. 180 degrees is the total measure of the angles of a triangle. And that equals this angle that I've drawn as a question mark plus an angle that's equal to it on the opposite side of the triangle plus 116 degrees. Okay, so now we pull out the calculator again, and we're going to say 180 minus 116, divide that by 2, and that gives us this. That tells us that this angle here that we were looking for is 32 degrees. Okay, so there we have our answer. Major concepts that we used here. The arc of a circle, right? The arc of a circle is equal to the angle corresponding to it. And we used the fact that all the way around the circle right here was 360 degrees. And we also used the fact that an isosceles triangle has angles adding up to 180 degrees. That goes for any triangle. But we used the fact that these are equal angles right here and right here to figure out the rest.